Magandang araw sa ating lahat. I am Engineer Peter Benjamin Obiano, your lecturer for this video. This is LBV GMath 1-2.5A, the first of the two videos na kung saan i-discuss natin how to solve the domain and range of rational functions. Now, this video is still under rational functions, the second chapter on our discussion on functions and their graphs. Now, this video and the next video will address the fifth MELC for rational functions, which is to find the domain and range of a rational function. This video will focus on getting the domain of the rational function. So, focus tayo sa pagkuha ng domain sa video na ito. For our topic outline first, i-review muna natin saglit paano ulit kunin ang domain ng isang function. And then, after nating i-review ang domain ng mga functions, let us now find out how to get the domain of a rational function. At the end of the video, I hope that we will be able to learn how to get the domain of rational functions. Now, para hindi tayo masyadong mahirapan sa discussion natin later, I hope na sa ngayon alam na natin kung paano mag-factor out ng polynomials and how to express a set of numbers using the set builder notation, interval notation, and the number line. Kasi later, pag i-express na natin yung sagot natin, gagamit tayo ng set builder notation, interval notation, and the number line. So, mas mainam, alam na natin kung paano gamitin ang mga notations na ito. Sige, review muna tayo. Paano kunin ang domain ng isang function? Definition muna tayo. The domain of a function is the set of all possible input values for a function. Let's say we have a function f and if magpapasok tayo ng x, syempre ang lalabas ay f of x. Now, let's focus on the input. So, dito tayo sa may input side. Ito ngayon yung tanong. Ano yung mga values na pwede mong gamitin as inputs? Halimbawa, kung real numbers ang pinag-uusapan natin, lahat ba ng real numbers pwede mong gamiting values ng x? Or may mga real numbers ba na hindi pwedeng gamiting values ng x? Now, sabi sa definition natin, ang domain is yung mga posibleng maging input ng function natin. Sila yung mga real numbers na pwede mo lamang gamitin bilang values ng x. So again, ang tawag natin sa mga values ng x na pwede mong ipasok sa function natin, ang tawag natin sa kanila ay domain. Sige, let's have an example. Let's say you have f of x is equal to x plus 1. Tapos tignan lang natin, let's observe kung anong mangyayari. Let's say nagpasok ako ng x na 1. Again, ano ang ginagawa ng function na ito? Ang ginagawa ng function na ito is, ano man ang ipinasok mo, dadagdagan niya ng 1. So, kung ang ipinasok mo ay 1, edi ang lalabas ay 2. Kung nagpasok ka ng negative 1, ang lalabas ay 0. Pag ang pinasok mo ay positive 2, ang lalabas ay positive 3. Now, let's focus on the input side. Let's ask ourselves, pwede ko bang gamitin lahat ng real numbers na values ng x? Okay lang ba na lagyan ng plus 1 lahat ng real numbers? The answer is yes. You can use any real number as inputs to this function. Since pwede mong gamitin lahat ng real numbers as values of x in this function, since you can use any real number as inputs to this function, the domain of this function is the set of real numbers. So, yun lang. So, our domain consists of all real numbers. Another example. Let's say f of x is squared. So again, ano ang gagawin ng function na ito? Ano man ang inilagay mo sa x, i-square niya. So kung naglagay man tayo kunyari ng positive 1, square, ang sagot ay 1. Maglagay ka ng negative 1, square, ang sagot ay 1 pa rin. Maglagay ka kunyari ng 2, square, so ang sagot ay 4. So, pag naglagay ka ng 0 squared, ang sagot ay 0, and so on. Again, if you want to get the domain, let's analyze. Lahat ba ng real numbers pwedeng gamitin as x? Lahat ba ng real numbers pwede mong i-square? Pwede mo bang i-square lahat ng real numbers? Yes. Therefore, you can use any real number as input. So, ano ngayon ang domain natin? Since pwede mong gamitin as x, kahit anong real number, the domain of x squared is the set of real numbers. Now, pwede nyo na lang tandaan to if you want, no? If you want a shortcut, just remember this one. The domain of any polynomial is the entire set of real numbers. Diba? Ang x squared ay isang polynomial. Yung example natin kanina na x plus 1 is a polynomial. So, basta polynomial siya, the domain is the entire set of real numbers. Sige, isang example pa tayo. What if our function is square root of x? So again, ang gagawin ng function natin, ano man ang ipinasok mo, i-square root niya. So kung let's say naglagay ka ng 1, square root of 1 is 1. Square root of 9 is 3. Paano kapag ang ipinasok mo ay negative? Take note ha, considering only real numbers, radical functions are defined only if the radicand, ano ulit yung radicand, yun yung nasa loob ng square root mo, the radicand is greater than or equal to 0. So, square root of x, alright, yung x mo dapat hindi negative. Pwedeng 0, pwedeng mas mataas sa 0. So, kung nagpasok ka kunyari ng negative 4, anong mangyayari? We don't know. It's undefined. Kasi nga, defined lamang ang square root of x kung ang x mo ay 0 or any positive number. So, ang tanong ngayon, pwede mo bang gamitin kahit anong real number as values of x? Lahat ba ng real numbers pwedeng i-square root? Makikita natin, hindi lahat. The value of x must be greater than 0 or equal to 0. Meaning, hindi pwede yung mga negative numbers. Ano ngayon ang domain natin? Therefore, ang domain natin ngayon is the value of x must be greater than or equal to 0. So, ganyan lang. So, ganun lang ang definition ng domain. Ano lang yung mga values ng x na pwedeng gamitin. Ano lang yung mga pwedeng gawing inputs sa function. Alright? Now, from what we learned, we can actually have more definitions for the domain of a function. Pwede rin ito. The domain of a function is the set of all values for which the function is defined. Pwede rin ito. The domain of a function is the set of all real numbers except those that will make the function undefined. So basta yung value ng x, hindi niya gagawing undefined yung function. Kasama siya sa domain. Or in other words, kung yung x gagawin niyang undefined yung function, hindi na ito kasama sa domain. Alright? So yun lang, yung tandaan natin. Kung magiging undefined siya, huwag mong isasama yung x na yon sa domain. By the way, yung huling dalawang definition natin, ito ang gagamitin nating basihan para sa rational functions. I hope naging malinaw po sa atin paano kumuha ng domain. Sige, let's now go to our topic, how to get the domain of rational functions. So again, definition, the domain of a function is the set of all values for which the function is defined. O di kaya, the domain of a function consists of all real numbers except those that will make the function undefined. Again, kung gagawin ng input mo na undefined yung function, hindi ito kasama sa domain. Ngayon, balikan natin ang rational functions. Kailan ba magiging undefined ang isang rational function? Recall na ang rational function ay may polynomials as the numerator and the denominator. So, yung f of x and g of x must be both polynomials. Mula sa nasabi natin kanina, ano ulit ang domain ng mga polynomials? Ang domain ng polynomials is the set of real numbers. This means na ang domain ng f of x ay lahat ng real numbers. Ang domain ng g of x ay lahat ng real numbers. So, pwede mong gamitin kahit ano ang real number sa f of x at sa g of x kasi nga, mga polynomials sila. However, take note, may problema tayo actually pag ginawa mo na silang f of x over g of x. Iniiwasan natin na magkaroon tayo ng division by 0. So, ibig sabihin nito, hindi pwede na ang value ng g of x mo maging 0. Kasi kung naging 0 yung value ng g of x mo, edi magkakaroon ka na ng division by 0. So, therefore, a rational function is undefined when the gx, yung denominator, ay magiging 0. Ito ngayon ang mga iiwasan natin. Iiwasan natin yung mga values ng x na gagawin niyang 0 yung nasa denominator. Okay, so again, when is a rational function undefined? A rational function is undefined when its denominator is equal to 0. Therefore, the domain of a rational function consists of all real numbers maliban sa mga values na gagawing 0 yung denominator. So again, the denominator must not be equal to 0. Therefore, the domain of a rational function consists of all real numbers except those values that will make the denominator equal to 0. Pwede ang lahat maliban sa magpapa-0 sa denominator. Ibig sabihin nito, actually, babantayan lang natin yung denominator. So, medyo hindi ganun kahirap ang pagkuha ng domain ng rational functions. Bantayan lang natin yung denominator. Sige, example tayo. Find the domain of x plus 1 over x. Again, so ulit-ulitin natin ito. The domain of a rational function consists of all real numbers except those values that will make the denominator equal to 0. So ito ngayon yung tanong, kailan ba magiging 0 yung denominator? So bantayan lang natin yung denominator. Simple lang naman yung denominator mo It's just x. Kailan magiging 0 ang x? Di syempre, magiging 0 yung x if x is 0. The denominator is equal to 0 when x is equal to 0. Therefore, hindi dapat maging 0 ang value ng x. Ito yung iiwasan natin. Therefore, ano ngayon ang domain natin? Thus, the domain of the function is, in words, all real numbers except 0. Lahat ng real numbers maliban sa 0. Kung i-express natin to as set builder notation, pwedeng ganito, So, our domain involves all values of x, which are all real numbers, such that x is not equal to 0. Okay? Di ba? Same lang naman yung sinasabi nito. Si x ay kahit anong real number, basta hindi siya equal sa 0. Kung gusto mo namang kunin yung number line equivalent nito, so gamitin ang number line, Again, 0 yung binabantayan mo, o di ilagay natin yung 0. Again, hindi dapat kasama yung 0. Di ba? Pag hindi kasama yung isang number, ang gagamitin natin ay isang whole. Ang gagamitin natin is hollow circle. Tapos, pwede na lahat. So, pwede hanggang negative infinity, pwede hanggang positive infinity, basta yung saktong 0, hindi kasama. So, therefore, i-shade lang natin to the left and to the right. Ngayon, kapag naman ang gagawin mong notation is interval notation, di ba, maging ganito siya. Magmula negative infinity hanggang bago mag-0 and magmula after 0 hanggang positive infinity. So again, basta infinity, laging parenthesis. Hindi kasama yung saktong 0, kaya ang gagamitin natin is parenthesis. Again, kung mayroon kang dalawang sets na gustong pagsamahin, gamit lang tayo ng union between them. And ito na yan. So this is now our domain, and this is how we can express our answer. Again, hindi naman ganun kahirap ang pagkuha ng domain ng rational functions. Bantayan lang natin. Ano ang mga magpapa-zero sa denominator? Yun ang mga iiwasan natin. Sige, other examples tayo. Find the domain of f of x equals x minus 3 over x plus 5. Again, the domain of a rational function consists all real numbers except those values that will make the denominator equal to 0. Ano ba yung denominator natin? It's x plus 5. So ito yung tanong, kailan ba magiging 0 ang x plus 5? E di ang gawin natin, yung x plus 5, i-equate mo sa 0, tapos diba, solving for x, you will get negative 5. Hindi pwede na ang value ng x ay maging negative 5. Kasi yun nga, pag ito, negative 5, edi mayroon ka ng negative 5 plus 5, 0 na yon. 0 na yung denominator mo. Hindi pwede. So yun lang naman yung iiwasan natin. Pwede ang lahat maliban sa negative 5. Alright, so the domain of the function is all real numbers except negative 5. In set builder notation, pwedeng ganito. Our domain consists of x, which is a real number such that x is not equal to negative 5. In terms of the number line, so sabi na natin, ilagay natin yung 0. Again, okay lang kahit wag mo nang ilagay yung 0. Pero kung gusto mo na medyo magandang tignan, pwede naman lagyan mo ng 0. Anyways, ang talagang kailangan nating ilagay dito ay si negative 5. So, lagay natin dito, siguro somewhere dyan, si negative 5. Hindi kasama yung negative 5. Kaya sa negative 5, maglagay tayo ng whole or hollow circle. Tapos, pwede na lahat. So, i-shade na lang natin to the left and then to the right of negative 5. In terms of interval notation, so, di ba, pwede magmula negative infinity hanggang bago mag-negative 5 and then after negative 5 until mataas na value approaching positive infinity. So again, negative infinity, positive infinity, laging parenthesis. Hindi kasama yung saktong negative 5, kaya sa may negative 5, maglalagay tayo ng parenthesis. We are combining two intervals, so let's just use union. So, ganun lang. So, that is how you get the domain. Exercise number 3, find the domain of x plus 4 over x squared minus 1. Now, minsan, para makuha natin yung values ng x na magpapa-0 sa denominator, sometimes, we need to do a little bit of factoring. Okay? So, i-factor out muna natin yung x squared minus 1. I hope naalala nyo pa. So, di ba, pag finactor out mo yung x squared minus 1, we will get x minus 1 times x plus 1. Okay? Sige. Ito nga yung tanong. Ano yung mga values ng x na magpapa-0 sa denominator natin? Ano yung mga values ng x na magpapa-0 sa denominator natin? Okay? So, nakita na natin yan. So, this is equivalent to this. Ano yung magpapa-0 sa x plus 1, x minus 1? So, di ba? Simple lang. O, di kunin mo yung x plus 1, equate mo sa 0, solving for x, ang lalabas ay negative 1. Kunin mo yung x minus 1, equate mo sa 0, masosolve mong x ay positive 1. Therefore, sa anong values ng x magiging 0 yung denominator natin? Magiging 0 yung denominator natin kapag ang ginamit mong x ay 1 o di kaya ang ginamit mong x ay negative 1. Therefore, iiwasan natin ang x equals 1 at yung x equals negative 1. Using our principle, again, the domain of a rational function consists of all real numbers except those values that will make the denominator equal to 0. Nakita natin kanina na ang denominator ay magiging 0 kapag ang x ay negative 1 or x is positive 1. Kaya itong dalawang to, yung mga hindi kasama sa domain. Therefore, the domain of the function is all real numbers except negative 1 and positive 1. In terms of set builder notation, pwedeng ganito. Our domain consists of all real numbers as long as x is not equal to negative 1 or x is not equal to positive 1. In terms of the number line, so again, para walang medyo magandang tignan, if you want, lagyan natin ng 0 sa gitna. Again, ang importante talaga dito ay yung negative 1 at positive 1. Hindi kasama ang dalawang to, kaya maglalagay tayo ng whole or hollow circle sa kanila. And then, i-shade na lang natin the rest of the number line. Yung papuntang negative infinity, yung gitna ng negative 1 at positive 1, and from 1 papuntang positive infinity. So this is our answer in terms of the number line. In terms naman of the interval notation, so again, from numbers approaching negative infinity up to negative 1, kaya lang yung saktong negative 1 hindi kasama, kaya parenthesis tayo. And then, magmula after negative 1 hanggang bago mag 1, so ito yon. So from negative 1 to 1, kaso yung saktong negative 1 at positive 1 hindi kasama, kaya parenthesis yung gagamitin natin. And lastly, magmula 1 until the numbers approaching positive infinity. Again, yung saktong 1 ay hindi kasama, kaya ang gagamitin natin dito ay parenthesis. We are combining 3 intervals, so gamit tayo ng union. Alright, so ganun lang. I hope clear na po sa atin kung paano mag-solve ng domain of rational functions. Again, hindi naman ganun kahirap. Basta bantayan mo lang kailan magiging 0 yung denominator. Yun yung mga hindi kasama sa domain. Sige, let's go to exercise number 4. Find the domain of f of x equals x squared minus x minus 6 over x plus 2. Again, minsan kailangan nating mag-factor out. So, i-factor out muna natin yung x squared minus x minus 6. Using our algebra, we will get this one. You'll get x plus 2 times x minus 3. Uy! Maka-cancel out yung x plus 2. Pag na-cancel out yung x plus 2, edi ang maiiwan ay x minus 3. Ano ba ang x minus 3? Hindi ba ang x minus 3 ay isang polynomial? Sabi natin kanina, basta polynomial, the domain is the entire set of real numbers. Therefore, the domain is all real numbers. Tama? Now, if ganito ang solution mo, this is actually wrong. Bakit mali? Okay, remember this one. Kapag kumukuha ka ng domain ng kahit anong function, kahit hindi rational, kapag kumukuha ka ng domain, ang lagi mong basihan pa rin is the original function. Huwag kalimutan yung original function. Hindi porket nawala yung x plus 2 sa numerator at denominator, okay na tayo. Actually, hindi. So again, Yes, sa bandang huli, pag sinimplify mo, magiging x minus 3. Kaya lang, wag mong kakalimutan yung original function. Take note, sa original function, kailan ba magiging 0 yung denominator, di ba? Kailan magiging 0 yung x plus 2? Magiging 0 yung x plus 2 if x is negative 2. So from the original function, x plus 2 is equal to 0 if x is negative 2. So kahit pa na noong sinimplify mo, ay parang okay naman lahat ng real numbers. Pero sabi nung original, ay hindi. Dapat hindi kasama yung negative 2. Ang masusunod pa rin is kung ano yung sinasabi ng original function. Okay po, so malinaw po tayo doon. No? Lagi tayong bumalik sa original function. Sige. Thus, the denominator will be equal to 0 at x is negative 2, meaning ang x is negative 2 hindi kasama sa domain. Let's now express our answer. So again, pag finactor out mo yung numerator, magiging ganito. And after simplification, magiging ganyan. Sige. So the domain of a rational function consists of all real numbers except those values that will make the denominator equal to 0. Again, the denominator of the original function is equal to 0 at x is negative 2. Therefore, what is our domain? The domain of the function is all real numbers except negative 2. In terms of set builder notation, our domain consists of all real numbers such that x is not equal to negative 2. In terms naman of the number line, so markahan natin yung negative 2 somewhere here, hindi siya kasama kaya maglalagay tayo ng whole. And then, i-shade na lang natin the rest of the number line. So from negative 2 up to negative infinity to the left, and from 2 up to the numbers approaching positive infinity, so to the right. In terms naman of interval notation, you'll get this one. So from numbers approaching negative infinity up to negative 2, and from negative 2 up to numbers approaching positive infinity. Again, yung saktong negative 2, hindi kasama, kaya ang gagamitin natin ay parenthesis. Again, reminder, for infinity, negative man yan or positive infinity, we will always use parentheses. And again, we are combining two separate intervals, kaya gagamit tayo ng union. I hope clear po ito sa atin. Now, for our last problem, let's have a more challenging one. Find the domain of x minus 3 over 4, x raised to negative 2 minus 16. I-simplify muna natin yung binigay. Recall the properties of exponents. Ang x raised to negative 2 is the same as 1 over x squared. So, yung 4x raised to negative 2 ay pwede nating i-rewrite as 4 over x squared. Tapos, gawin natin, let us simplify this one para iisang fraction lang siya. Sige. So, unahin natin yung denominator. Ano ba ang LCD ng 4x squared at negative 16? Hindi ba x squared? X squared divided by x squared is 1. 1 times 4 is 4. X squared divided by, of course, parang naka-divide to ng 1. So, x squared divided by 1 is x squared. X squared times negative 16 is negative 16x squared. Then, let us perform division of fractions. So, you'll get x minus 3 divided by 4 minus 16x squared over x squared. Ano ulit ang ginagawa natin pag ganito, di ba? Kukunin mo yung reciprocal ng divisor. So, i-reciprocal mo si 4 minus 16x squared over x squared. Makukuha natin to. Tapos yung division ay magiging multiplication. So, let us multiply this one. We will get this. So, ito ay equivalent dito. Okay? So, from our previous solutions, di ba? Again, ang x raised to negative 2 is the same as 1 over x squared. Na again, using algebra, this is equivalent to this. Alright. So, balik na tayo sa tanong natin. Sa anong mga values magzi-zero ang denominator natin? So, ang denominator na natin ngayon is 4 minus 16x squared. Kailan ba ito magiging 0? So, let's just use algebra na lang. So, 4 minus 16x squared, i-equate natin sa 0. Alright, transpose natin yung 4 sa kabila, magiging negative 4. Divide both sides by negative 16. So you'll get x squared is equal to 1/4. Of course, solving for x, it's just the square root of 1/4. Hindi ba? Pag tayo ay mag-i-square root, dalawa ang makukuha nating sagot. Isang positive, isang negative. So therefore, the square root of 1/4 is positive 1/2 and negative 1/2. Ito ngayon yung mga values ng x na magpapa-0 sa denominator. Alright, so ito yung nakuha natin from the previous step. The denominator is equal to 0 at x is negative 1/2 or at x equals to 1/2. Again, since sila yung magpapa-0 sa denominator, hindi sila kasama sa domain. Therefore, ano ngayon yung domain ng function natin? Di all real numbers except negative 1/2 and positive 1/2. In terms of set builder notation, we will have this. So x is a real number such that x is not equal to negative 1/2 or x is not equal to positive 1/2. Using interval notation, we should get this one. Okay. Ito na ba yung sagot? Actually, no. If this is your answer is actually incomplete. Nakuha mo naman yung negative 1/2 at 1/2. Tama naman na hindi sila kasama sa domain. Kaya lang medyo kulang yung solution natin. Bakit kulang yung solution? Again, kagaya ng nabanggit ko kanina, lagi tayong bumalik doon sa original function. So, lagi tayong bumalik sa original function. Okay? Again, yung x is negative 1/2, x equals 1/2 na mga iiwasang value para sa simplified function yon. Para yun kay x cubed minus 3x squared over 4 minus 16x squared. Para sa kanya yon. Paano dun sa original? So, balik tayo saglit sa original. Let's take a look. Okay? May dapat ba tayong iwasan? Makikita natin, meron. Let us focus on 4 over x squared. Let's focus on this. Okay. Ayaw natin na magkaroon ng division by 0 sa part na ito. So kung ayaw mong magkaroon ng division by 0, ano ang iiwasan natin? Hindi ba ang x squared ay magiging 0 if x is 0? Therefore, hindi pwede ang 0 dito. Kasi kapag naglagay ka ng 0 dito, magiging undefined to. Pag ito undefined minus 16, edi undefined pa rin kasi hindi natin alam. Something divided by undefined, hindi nga natin alam kasi undefined in the first place yung nasa baba. So wala tayong makukuhang value. Pwede nyo actually confirm. I-type nyo to sa calculator if you want. I-type mo to sa calculator. Tapos, yung x, palitan mo ng 0, malalaman mo, math error siya. So, mali, sasabihin ng calculator. Hindi pwede. Yan. So, you can confirm if you want. So, again, yung x equals 0 ay hindi pwede doon sa original. Pwede yung x na 0 dito sa simplified. Dito sa nire-write. Pwede yung x na 0. Kaya lang, hindi siya pwede doon sa original. Kagaya na nabanggit ko kanina, i-consider mo pa rin yung original. So, sabi ng original function, hindi pwede yung 0. So, sabi ng original, hindi pwede ang 0. Sabi ng simplified, hindi pwede yung negative 1/2 at positive 1/2. Ano ngayon ang domain natin? Therefore, ang domain na natin ngayon is lahat ng real numbers maliban sa tatlong to. Maliban kay negative 1/2, 0, at positive 1/2. So, ganun, paghalu-haluin mo lang lahat ng mga hindi pwedeng values. So yun na yan. Ito na po yung ating domain. Alright, in terms of set builder notation, so x is a real number such that x is not equal to negative 1/2, or x is not equal to 0, or x is not equal to positive 1/2. In terms of the number line, so again, lagyan lang natin ng 0 sa gitna, and then let's say nandito si negative 1/2, nandito si positive 1/2. Hindi pwede itong tatlong to, kaya maglagay tayo ng whole sa kanila. Okay? Tapos, i-shade na lang natin the rest of the number line. Ito na yan. Ito yung sagot natin in terms of the number line. Lastly, in terms of the interval notation, so ilang intervals na ngayon? 4 na. Ano? From numbers approaching negative infinity up to negative 1/2. Kaya lang yung negative 1/2 hindi kasama, kaya parenthesis. And then, magmula negative 1/2 to 0, yung saktong negative 1/2 at 0, hindi kasama, kaya pares na parenthesis. Next, from 0 to 1/2, yung 0 at 1/2, hindi kasama, kaya pares na parenthesis. And lastly, from 1/2 up to the numbers approaching positive infinity. Again, hindi kasama yung saktong 1/2, kaya parenthesis tayo. For negative infinity and positive infinity, let's use parenthesis. We are combining intervals, let us use union. And ito na yan. This is now the domain of this function. So again ha, sa pagkuha po ng domain, bantayan yung original, bantayan mo din yung simplified. Pagsama-samahin lahat ng values ng x na hindi kasama. So I hope clear po iyon sa atin. Alright, we are now done with our video. I hope na naging malinaw po sa atin paano kumuha ng domain ng mga rational functions. We are now done with LBV 1-2.5a. Next video will be on 1-2.5b. In this video, nag-focus tayo sa domain. Sa next video, ang focus naman natin is finding the range naman. Okay, so again, for additional problems, you may refer to QuexBook on General Mathematics, Chapter 2. God bless po and see you sa next video.